Have you ever looked up at the night sky and seen Venus, that bright, beautiful star? It's often called Earth's twin, and for good reason. From a distance, they look almost identical. They're nearly the same size, made of the same rocky stuff, and orbit in the same neighborhood of our solar system. You'd think they'd be two peas in a pod, right? But as you get closer, you realize one of these twins took a drastically different path. One became our home, a vibrant paradise teeming with life, while the other turned into a living nightmare. This is the story of the twin paradox, and it holds crucial lessons about our own planet's future. So, what went so wrong with Venus? Imagine stepping onto its surface. The first thing you'd notice, or rather, feel, is the crushing pressure. It's over 90 times greater than what we experience on Earth, equivalent to being nearly a kilometer deep in the ocean. Then, there's the heat. It's a blistering 465 degrees Celsius, hot enough to melt lead. This isn't just a hot day, it's a planet-wide furnace. The sky isn't blue. It's a murky yellowish-orange, shrouded in thick clouds of sulfuric acid. Forget about water, oceans, or life. Venus is a sterile, toxic wasteland. How did two planets, born from the same cosmic dust cloud, end up so wildly different? The answer, scientists believe, lies in a runaway greenhouse effect. Early in its history, Venus might have been much more like Earth. It may have had liquid water, oceans, a milder climate, and maybe, just maybe, the building blocks for life. But something tipped the scales. Venus is a bit closer to the Sun than Earth, receiving about twice the solar energy. This extra heat likely caused its oceans to start evaporating faster. Now here's the crucial part. Water vapor is a powerful greenhouse gas. As more water evaporated into the atmosphere, it trapped more heat. This trapped heat, in turn, caused even more water to evaporate. It was a vicious cycle, a positive feedback loop that just kept spiraling out of control. The planet got hotter and hotter, until eventually, all the oceans boiled away completely. Without oceans to absorb carbon dioxide, the CO2 from volcanic eruptions just built up in the atmosphere, creating the thick, suffocating blanket that smothers the planet today. The sun's intense ultraviolet radiation also played a role. It zapped the water vapor molecules in Venus's upper atmosphere, splitting them into hydrogen and oxygen. The light hydrogen atoms were so energetic that they escaped into space, forever lost. The oxygen likely combined with other elements on the surface. Without hydrogen, water could never form again. Venus lost its water for good, sealing its fate as a dry, barren world. So, we have Venus, the evil twin, a cautionary tale written in the sky. And then we have Earth. Our planet found a delicate balance. It was just the right distance from the sun for liquid water to exist. We developed a carbon cycle where oceans, rocks, and life itself worked together to regulate the amount of CO2 in the atmosphere, acting like a planetary thermostat. Plate tectonics constantly recycle the Earth's crust, burying carbon in rocks and preventing it from overwhelming the atmosphere. And most importantly, we have life. Photosynthesis, carried out by plants and algae, actively removes CO2 from the air and releases the oxygen we breathe. Earth's climate system is an incredibly complex and beautiful dance of geological and biological processes. For billions of years, this dance has kept our planet in the Goldilocks zone, not too hot, not too cold, but just right, for life to flourish. But the story of Venus forces us to ask a chilling question. How stable is our paradise? Could Earth ever suffer the same fate? This is where the twin paradox becomes incredibly relevant to us, right here, right now. While Earth is not in immediate danger of becoming a Venus-like furnace, the fundamental physics are the same. We are currently conducting our own unplanned experiment by pumping massive amounts of greenhouse gases, primarily carbon dioxide, into our atmosphere. We are, in effect, turning up the heat on our own planet. The changes we're seeing: rising global temperatures, melting ice caps, More extreme weather events are all symptoms of this same greenhouse effect that ran amok on Venus. Our planet has natural buffers, like the oceans, that absorb a lot of this extra heat and CO2. But these buffers have limits. As the oceans warm, their ability to absorb CO2 decreases. As they become more acidic, it threatens marine life, a key part of the carbon cycle. We're pushing a system that has maintained a delicate equilibrium for eons. The story of Venus shows us what happens when a planet's climate system is pushed past its breaking point. It demonstrates that a planet's climate isn't inherently stable. It can undergo dramatic, irreversible shifts. We don't know exactly where Earth's tipping point is, but Venus serves as a stark reminder that such a point exists. Understanding Venus isn't just an academic exercise for astronomers. It's a critical part of understanding our own world. By studying its runaway climate, we can refine our models of Earth's climate, helping us better predict the consequences of our own actions. It gives us a glimpse into a possible future, a warning from our long-lost twin about the fragility of the paradise we call home. The contrast between these two worlds is a powerful lesson. It highlights the unique and precious nature of Earth. We live on a planet that, through a combination of cosmic luck and intricate natural cycles, managed to become a haven for life. The twin paradox urges us to appreciate this delicate balance and to act as responsible stewards of our planetary home, ensuring that Earth remains a paradise for generations to come and never follows its twin down that dark, scorching path. Thank you so much for watching. If you found this cosmic story as fascinating as I do, please hit that like button and subscribe for more deep dives into the wonders of our universe. Let me know in the comments what you think. Is Venus a warning we should be taking more seriously? See you in the next video.